Welcome to part 3 of our series. At this point, you should have a basic understanding of GLSL and fragment shaders. In this part, we're going to show you how to change an existing shader, as well as convert shaders from the internet to run on Structure, and then load them onto Structure so we can use them in our performances. All of the generator Structure fragment shaders are in the Shader Sandbox website, and I'll have a link in the description. These shaders can be browsed by thumbnail or searched for by name. First, let's take a look at a shader running on Structure, and we say we might want to change this. Here we have a knob that's changing our density, one that is changing squares, and another that is changing color. So that looks pretty neat, but how would we go ahead and edit this? What we can do is press the display button twice until we're on the Files menu, and here we can see that the fragment name is Dance Floor. So the fragment shader will be called dancefloor.glsl. If we press the display key again, we'll go to the parameters menu, and here we can see that scale is mapped to CV1X, squares is mapped to CV2Y, and color position is mapped to CV3. So we'll go back to the GLSL Shader Sandbox on the Erogenous Tones website, and we can enter in Dance Floor and click Submit. Here we'll get a thumbnail of the Dance Floor shader, and if we click it again, it will launch and run inside a WebGL context in our browser. So here on lines 1 through 9, we can see our reserved variables that Structure uses to communicate with the shader, and then below that, on lines 10, 11, and 12, we can see the names on the parameters page. If we wanted to change the shader, we can test our edits here, and if they compile, we can transfer them to Structure and run them. If you have an error in your GSL code, the line will highlight red and the status window will say compiled with problems in red. Example, if I accidentally hit some keys here, we'll see that the line goes red and it says compiled with errors above. So if we remove that, it will recompile, and when it compiles correctly, the box says compiled successfully. So let's make a change here. Say we want our scale to be even greater than it is. We see the float F0 was assigned to CV1X, and that variable is right here in our code. So maybe we'll change that 8 to an 80, and look at that. And then we can kind of test our change. There's our full out, and there's our full in. I like that a lot. If we're happy with all of the changes, we then select all of the text and open up a text editor like Simple Text on the Mac or Notepad on Windows or VI on Linux. And we can paste the text into the shader, and we'll save this to our local hard drive. And I'll call this dancefloor2.glsl. To use the new shader on Structure, you'll need to remove the front SD card from Structure and mount the drive on your computer. It is formatted as FAT32, so it should be readable on most modern operating systems. If you're using the factory-supplied front SD card, it will appear as struct_SD on your desktop. Open the SD card and navigate to the GLSL folder. The subfolders here represent the different type of node shader and other user data location that Structure accepts. Since we're working on a generator, which is abbreviated as GEN, we will open the gen directory and copy our GLSL text file into that directory. Then we'll eject this micro SD card and we'll place it back in the front SD slot on Structure. When we reinsert the SD card on Structure, we'll get a message saying that the SD card was inserted and that Structure needs to restart in order to load the new changes. Okay, so let's load up our new shader by pressing the list key and finding it alphabetically in the list of shaders. We're Dance Floor 2. There we go. Close that window. And here we see our shader with a much more pixelated scale. And if we press our display button twice, we'll see the frag name is Dance Floor 2. Pressing it one more time, we see our variables. Now we move on to a bigger challenge, converting a fragment shader we found on the internet into a gen shader that Structure can use. This shader on GLSLSandbox.com was suggested to be used as an example by a member of the Structure Visual Generator user group on Facebook. At first glance, I've got a good feeling about this shader and that we will be able to convert it to work with Structure. It doesn't have an awful lot of lines of code. It doesn't do any ray marching or recursive loops. There are not any incoming variables that Structure can't handle, and it doesn't have any loops that repeat a large number of times. In GLSL, every for next loop needs to be unrolled in memory, so a loop that iterates 100 times will more than likely cause an out-of-memory error, and that might require Structure to be rebooted. First, I'm going to set this color variable to equal a vec3 of 0.0, and that's going to turn all of the pixels black, so it's a little bit easier to examine the code. At the top, we have some WebGL and GLSL configuration flags. We do not need these for Structure. Next, we see the environment variables that GLSLSandbox.com uses to interact with the shader. We already defined time and resolution, so we don't need those, and it doesn't look like the shader is using the variable mouse, so we don't need to copy that either. For shaders that do use the mouse, we generally add a line to set a mouse equal to a vec2 of f0 and f1. Next, there are two functions, grid and circle. They look straightforward and don't need any changes. We'll need to copy those over. And then there's the main routine. Not seeing anything too complicated here. So, a really quick note on style here. Before we copy just the text we need from this shader, I want to make a note of where we found it. Generally, on the line above the main subroutine, I'll make a copy of the URL and add it as a comment by leading the line with 2 forward slashes and then pasting the URL. Next, we're going to copy everything from the grid subroutine to the last right curly brace at the bottom. Now we're going to open the Shader Sandbox gallery and we're going to click on the Create New Generator link. We're going to remove everything from line 20, which starts with void main, to the end, and instead we're going to paste from the clipboard the shader we just copied. We'll make sure to remove the color equals vec30 here, so we can see how it renders. That looks pretty good. Before we save this shader to a .glsl file, let's add a modifiable parameter. On line 28, it seems to be sending a value of 100 to the radius of the circle. Let's see what happens if we change that to 300. Okay, it looks like we're going to increase the radius. I like that. So let's take that 300 and multiply it by f0, which is the variable we have coming in the fparams array from Structure, and that's by default mapped to cv1x. Now, when we simulate changing the value of f0, looks pretty good. Put that on a side. Okay. So since we've changed that, let's go here into the comments on line 10 for f0, and let's just call this radius. We'll then follow the same steps of selecting all of the text, though we don't really need the precision float medium P up top. We'll go to our text editor, we'll paste this, and we will save this as test shader. So we'll save it as AAA test shade.glsl. All right, once again, we'll remove the SD card from Structure and we'll mount this on our computer. We'll open the struct_SD card, open the GLSL folder and the gen directory. We'll copy our AAA test shade into gen. A quick note, Here, if you wanted to add images to be used by the image node generator, you can load PNG file images that are 720 by 480 pixels. Those can be dragged directly into the image directories and will appear when you load the image node. Going to eject this from our system. We reinsert the card into Structure, and it will prompt us to restart. Once we're back up, we'll press the List Soft key, then hold the Jump key and dial counterclockwise until we get to the A's. And there's our shader up top, AAA Test Shade. Let's load that, and then close this window. Now we can move our CV1X, and we should be able, as we are here, changing the radius of the circle. If we press the display button twice, we see our name as AAA Test Shade, and we press it one more time, and we see CV1X is routed to our radius variable that we set. Thank you for watching our videos. If you have any questions, you can reach us at the Structure Visual Generator user group on Facebook or at erogenoustones.com.